space elevator or space lift is an imaginary technology through which in the future it might be possible to travel to space without rockets. Just as we use elevators instead of stairs to easily climb tall buildings, similarly, using this space elevator, it would be possible to reach space from Earth at a very low cost without burning huge amounts of rocket fuel. Currently, when traveling to space by rocket, Earth's gravity pulls the rocket downwards. To overcome this pull and reach space, rockets need to generate enormous energy, costing billions of dollars. But if such an electric elevator can be built that can repeatedly go up and down from Earth to space, then space travel will become much easier, safer, and affordable. Scientists envision that dream through the idea of the space elevator. Such a device has not yet been built in reality. However, due to extensive progress in science and technology, hope around space elevators is increasing day by day. One day in the future, we might actually be able to travel to space by riding an elevator. In this episode of Brain Boost, we will discuss what a space elevator might be like, why it is important, and how it could work. The concept of a space elevator is not new at all. In 1895, Russian space scientist Konstantin Tsiolkovsky wrote about an imaginary tower more than 36,000 kilometers tall in his book Dreams of Earth and Sky, though he did not provide detailed discussion or calculations. Later in 1960, another Russian scientist Yuri Artsudanov wrote about a satellite from which a long cable would extend toward Earth and another cable would go into space. Spacecraft would travel along this cable. He compared the concept to a space railway. A space elevator will be made of four main parts: tether or cable, anchor, counterweight, and climbers. The tether or cable is a long, very strong material similar to a wire. The anchor is like the anchor of a ship, firmly fixed to a place on Earth. The counterweight is connected at the other end of the cable and will have a space station. This station will work as a launch point for spacecraft and satellites. The climber will move up and down from the anchor on Earth to the station in space. This can be compared to the elevator in a building. It is not very difficult to imagine what a space elevator might look like. Imagine a child tying a thread to a toy and spinning it around, holding the other end of the thread. Now, an ant starts walking from the child's hand along the thread toward the toy. This is like a tiny space elevator. The child's hand holding the thread firmly acts as the anchor. The thread is the cable, and the toy is the space station. To build a real space elevator, some other things must be considered. When the child spins the toy by the thread, the child spins it freely as they wish. But we cannot spin the space elevator freely. It will rotate because of Earth's rotation. Here also, there are complexities. The elevator cannot be anchored anywhere on Earth. It must be anchored along the equator. And because it requires a large area, it will be built over the Atlantic Ocean. What if the thread suddenly breaks while spinning? The toy would fly off. The toy always wants to fly away while spinning, but the thread prevents it. Similarly, anything orbiting outside Earth tends to fly away but is held by Earth's gravity. If an object orbiting Earth has an angular velocity equal to Earth's, it would fly away at about 35,786 kilometers from Earth. This orbit is called the geostationary orbit because a satellite there always sees the same spot on Earth. No net force acts on that satellite. If our space station is at this distance, the cable will have no tension. But to keep the cable taut, the station must be farther than the geostationary orbit, anywhere from 5,000 to 100,000 kilometers away. If a space elevator can be built, it will undoubtedly be the largest structure on Earth, extending from land beyond the horizon and far into the sky. But many obstacles remain. Among the four parts of the space elevator, all except the cable can be built in some way. There are already 2 space stations orbiting Earth. Climbers and anchors are not major concerns for scientists. The main challenge is manufacturing a very strong and long cable that can connect Earth to the space station. Because of Earth's gravity gradient, the cable must be thicker near Earth and thinner near the space station. Many think the cable should be made of steel, but steel's weight compared to its strength is too much, making such a cable impossible. Scientists are searching for alternative materials like Kevlar, graphene, and carbon nanotubes. The most hope is in carbon nanotubes, a material made of carbon that is 100 times stronger than steel. It is also very light and heat resistant. But the problem is that very long carbon nanotubes have not yet been produced. The longest produced is only 50 centimeters, while the space elevator requires an enormous length. Even if the cable can be made in the future, there are other challenges. There is a large amount of space junk orbiting Earth, old satellites, and rocket debris. There are about 120 million pieces smaller than 1 centimeter. These junk pieces will frequently hit the cable or space station. Also, radiation increases with altitude and may damage the cable. If the cable breaks for any reason, it could cause a catastrophe on Earth. Scientists need to find solutions to these problems. Moreover, climbing the cable will require a huge amount of energy. Where this energy will come from is another question. Scientists are considering nuclear or solar power for this. Rockets carry various instruments and equipment called payloads. The heavier the payload, the more fuel the rocket needs. Most rockets today are single-use, making space travel very expensive. But if the space elevator becomes reality, the cost to carry each kilogram of payload to space could drop from $20,000 to just $200.